Hello and welcome back to another past paper. We've got paper 1 from May-June 2023 for computer science, and it's a syllabus for 0478 IGCSE and O-level. Okay, so we're looking at paper 1. Please bear in mind that you will be sitting two papers. The algorithm programming and logic paper, paper 2, again weighing 50%, 75 marks in total, exactly the same as paper 1, which is your theory paper, computer systems, and we're looking again at a total marks of 75. Please note that no calculators are permitted on either paper, which you might find a little bit tricky, especially with the first few questions on this paper. Okay, let's get started. So 1 hour, 45 minutes. As I said before, we are not allowed to use a calculator on this paper, and the total marks is 75. So we've got binary is a number system used by computers. Tick one box to show which statement about the binary number system is correct. Is it a base 1 system? No. Is it a base 2 system? Well, yes it is. Is it base 10? No. Is it base 16? It's base 2. Why is it base 2? Because binary is only zeros and ones, whereas base 10, the one we know, would be 0 all the way through to 9. So there'd be 10 numbers in that system. But binary, zeros and ones, is basically base 2. Okay, here we go. Denary numbers are converted to binary numbers to be processed by a computer. Convert these 3 denary numbers to 8-bit binary numbers. So what I'm going to do first of all is because I've got to do this, this, and this. So I'm going to do, and it's talking about an 8-bit binary number system. So let's do 1, 2, 4, 8, 16, 32, 64. So that's 1, 2, 3, 4, 5, 6, 7, 128. That gives us 8-bit. So first of all, 50. It says 8-bit numbers, so there's 128 doesn't go into 50. Neither does 64. But 32 would go into 50. And 50, take away 32, would leave us with 18, which means 16 would go in, and there would be 2 left. Okay, so we can say there's none of those, 1 of those, and none of those. So the 8-bit number for 50 would be 0, 0, 1, 1, 0, 0, 1, 0. So 102. So we're referring to 102. Again, none of those, but 164. So 102 minus 64 would give us 36, 38. So that means there's 1 of those. So minus 32 would equal 6 left. So none of those, 1 of those, 1 of those, and none of those. So again, 0, 1, 1, 0, 0, 1, 1, 0. Okay, do you see what I'm doing? We'll have a little go at the last one, because the last one does have a 128 in it. 221. How many does 128 first of all go into 221? Well, yes, it does. But how many is left? So 2, 2, 1 minus 128. Well, I'm just going to do it like this. 3, I've got 1 left over, so I've got to pull that there and that there. 93, I believe, is left. 1 there, so 93 minus 64 would give us a total of 70 plus 6, 29. So 0 there, 1 of those, 29 minus 16, gives us 3, 13. 1 of those minus 8 equals 5. So 1 of those, none of those, and 1 of those. Okay, so we're basically putting these numbers here, into this number. How many of those go in? Yeah, if there's anything left, will 1 of those then fit in? Anything left, will 1 of those fit in? Okay, so 1, 1, 0, 1, 1, 1, 0, 1 would give us the full 3 marks. And we're only allowed to write in black or blue pen on the exam paper. This is just for your benefit, okay? So let's go on to C. Now we've got something a little bit strange here. 1 mark for binary systems are stored in registers. Okay, fair enough. Negative Denary numbers can be represented as binary using 2's complement. That basically means where this is minus 128. Okay, it's the 8-bit number system, but rather than having a full 255 numbers, we can only have this sort of positive or negative 128 each way. So I'll put these back in as we've just done. 4, 8, 16, 32, 64. Okay, so if you've seen some of my previous videos, you'll know how to do this, but it is does take a little bit of getting used to. But there's a wonderful video on 2's complement and negative binary numbers. So what do we need to do? We need to get minus 128. It's a minus number, so we've got to put it here. We've got to put a 1 in there to signify that it's a minus number. Okay, but then we've got to work out how many's left in terms of this minus 78. So I've got my working space here, 128. Yeah, and I've got to basically get to 0. So minus 128. And if I add 70, if I add, sorry. So I've got one of those, I've got 178. So let's have a little look at how we get to minus 78. So this, we can ignore this. Okay, so what we can do, I'm just going to change the colour of the pen. We need to add some numbers to this to get it up to minus 178. It's basically working down the number line. Okay, so let's make a start on this. Minus 128. If I add 64 to it, I'm going to end up with minus 64 because I've gone back up the number line, so to speak. So I'm adding positive 64 to 128. I've gone back up the number line to minus 64. Now minus 64 is going too far because we need to get to minus 78. So I can't use that. But if I go minus 128 plus 32, well, I think we're going to be okay here because that should equal minus 96. So minus 96. So what else do we need? Well, 96, we should be able to get the 16 in there as well. What have I got left? If I take the 16, so minus 96 plus 16, 0, and I'm going to be on 80 minus 80. So I'm going to put that in there. What have I got left? I've got a 2 left. Okay, I've got to get from minus 80 to minus 76. So minus 80 to minus 78. Well, I'm going to be needing to add 2 to it. So that means none of those, none of those, one of those, and none of those. Okay, so that would be in my register. 1 0 1 1 0 0 1 0. And just to check that, 32 plus 16 plus 2, so that's 6 7 8 9 10 0 and 1 3 1 3 plus 1 plus 1 is 50 minus, so 128 minus 50 equals 78. Okay, minus 78 in there, that's the same as that, we're okay. Okay, I'm just going to zoom in a little bit so you can see this a bit better. 2 8-bit binary numbers are given. Okay, yeah, they are. Add the 2 8-bit binary numbers using binary addition. Okay, give your answer in binary, show all your working out. Okay, using binary addition. Here we go. 1 plus 1 is 2. but we've only got zeros and ones in binary. So we put 0 down, carry the 1. 1 plus 0 is 1, but we've got another 1 there, so it's 2 again. So we've got 0, carry the 1. 0 plus 0 is 0, plus 1. Okay, 0. 1, 0. 1 plus 1 is 2, so 1, carry the 1. 1 plus 0 is 1, but we've got another 1 there, so we 0, carry the 1. So that would be our answer. 1, 0, 0, 1, 0, 1, 0, 0. So basically 1 nibble and 2 nibbles, and they're correct. Yeah, so we've got 4 carries. You saw that, yeah? I had to carry 4 times. 2 binary numbers are added by a computer and an overflow error occurs. Explain why the overflow error occurred. Okay, let me show you first of all what it means by an overflow. So if I go 1, 2, 3, 4, 5, 6, 7, 8, and I go, and that's like the maximum number in an 8-bit register, that would equal 255. All these numbers added together, 1 to 8, 64, all the way down to 1 would equal 255. Now if I added another number to it, and it can be any number, let's just go, in fact, let's just add a 1 to it. Okay, so we know that if we add a 1 to that, it would equal 256, but 256 would give us 9 bits. So if I go 0 there, carry the 1, okay, 0, carry the 1, 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 1 plus 1, I've got to go 0 and 1. Okay, we've then gone into a 9-bit register. That is too large, okay? That is too large, it's become 9 bits. If it's remained an 8-bit register, the number would be 1, 1, 1, and it would be 0. Well, it's not, it's 256, but the register would show an error because it would be 0. So basically, if we get 2 marks, the result is greater than 255, okay? And 2, it is too large to be stored in register. You could put the result requires more than 8 bits. Okay, but 2 things. Okay, it's 2 marks, we need 2 things. The result is greater than 255. The result requires more than 8 bits. Too large to be stored in a 8-bit register. Okay, that gives you the full marks. Okay, and it's only 2 marks. Okay, question 2. A student has a sound file that is too large to be stored on their external secondary storage device. The student compresses the sound file to make the file size smaller. The compression method used reduces the sample rate and the sample resolution of the sound file. State what is meant by the sample rate and the sample resolution. Well, let's start with the sample rate. Okay, basically the sample rate is the number of samples taken in per second, but that might be a little bit confusing. So if you think of it, your sample rate as your favorite song. Now imagine that this song is made up of a series of pictures that your computer takes really, really quickly to create the sound. So basically, I know it's not, but I'm just trying to use an analogy. The sample rate is how many of these pictures or samples the computer takes in just 1 second. So it's like asking how many snapshots of the music does a computer take every second. So imagine if you took 1 picture per second at a concert, you might miss a lot of the cool moments. But if you took 10 pictures per second, you'd capture more detail. And it's the same in terms of the sample rate. The more pictures you capture, the more detailed the song is going to be. The more chance you're going to capture. It helps capture more detail in the music, making it sound better and more like the original version. Okay, so sample resolution, that's a different thing as well. If I use the analogy of pictures, and we're talking about the colors in the pictures, imagine each of those snapshots in a music sample can only use a few colors to represent the music. The bit depth is like the number of colors available for each snapshot. If you just have a few colors, it's like having a basic colouring set with only a few crayons. But you have lots of colours, it's like having a big box of crayons with many shades. The bit depth works in the same way. It determines how many different shades of sound can be represented. So, again, the higher the bit depth, the more level of detail and accurate representation of the music is going to be. So if we write this down, the sample rate, it is the number of samples taken in a second, in 1 second. The sample resolution is the number of bits per sample. This is the number of bits per sample. Okay. Now identify which type of compression has been used to compress the sound files. Well, we've got two different types. We've got lossy and we've got lossless. And if we think about lossy being used for sound files, movie files, things like that, and pictures, and lossless being used for things where we can't afford to get rid of anything, so things like text, computer programs, things like that would be lossless. But lossy would be used here. It's only worth 1 mark, so you could just write the word lossy. Okay, so let's move on to C. The student sends a sound file to a friend. The file is transmitted across a network that uses packet switching. Identify 2 pieces of data that would be included in the header of a packet switch. The header of a packet. Okay, so the header usually contains the packet number, and there's a beautiful video I've created on this, on packet switching. But the packet number, because if it's broken up into different packets, then each of those packets would have its own unique number. It also needs to, we need to know where it's going to, and we also need to know who is sending it. So the destination, the receiver, basically, okay, which is usually in the form of an IP address. So the destination, and we could also put, I'm not going to put it on here, but the original sender as well. Okay, and again, that would be an IP address. So that's 2 marks, packet number and destination. Number 3 for 5 marks. I'm going to try and do this as a bullet list because I know some teachers say, oh yes, you write as a paragraph or several paragraphs, but you tend to waffle. And I've seen this many times marking exam papers, and they'll say the same thing, or they'll rewrite the question for no reason at all. You're not going to get a mark for rewriting the question. So if it's worth 5 marks, let's try and think of 5 things we can include. I'll explain how a file is transmitted using packet switching. Okay, well, first of all, data is split into packets, and it's packet switching. So a large amount of data is split into packets. Okay, each packet can take a different route along a network. Route, and we mentioned a router controls the route the packets take. So that's 3 things already. I'm going to put in here also called nodes. You may have heard of the term nodes, so you could put the nodes control the which way the packets are going across the network. Packets could arrive out of order. If a packet doesn't arrive, it is reordered. Once the last packet arrives, the packets are put into the correct order. Okay, so that would give us 5 marks because we've talked a lot about all the different things that happen. So data is split into packets, each packet is sent on a different route across the network. The routers or nodes control the route of the packets. Packets could arrive out of order. If a packet doesn't arrive, it is reordered. Once the last packet arrives, the packets are put back into their correct order. Okay, that will do for that. Question 3. Secondary storage devices are used to store data in a computer. Circle 3 components that are secondary storage devices. Oh, a nice easy question for us. Well, let's have a look. A secondary storage device would be something like a hard disk drive, okay, or a solid state disk. So we've got the first 2 dead easy, okay. But what's the other one? Secondary storage. Well, RAM or ROM it's not going to be. This is primary storage, RAM and ROM. The CPU is obviously something different. Sensors and registers. A register is something that's inside the CPU. So it must be a compact disk. Okay? It is secondary storage despite it being portable. Okay? Please don't think that just because it's portable, it's not classed as secondary storage. Something like a USB flash drive could also fit into secondary storage devices. Okay, part 3B. Tick one box to show which statement about secondary storage is correct. It is directly accessed by the CPU. No, it isn't. It is magnetic storage only. No, it isn't solid state. CDs are not magnetic. It is used to permanently store software and data files. It is volatile. Volatile basically means if the computer's turned off, whatever's been saved disappears. So it must be a process of elimination. It must be C. It's permanently stored, and don't worry about that. It's permanently stored software unless we choose to delete it. So it's not a question of if the computer is turned off, it goes, such as a volatile memory. It is permanently stored. We can take it away and store it forever. Okay, more missing words. Nice. We like missing words. We get lots of marks if we know the right words in the right order. Complete the statements about different types of software. Use the term from the list. Some of the terms in the list will not be used. Okay, you should only use a term once. Well, that's good then. Something software provides the services that the computer requires. An example is utility software. So I'm already thinking operating system. So I would go operating system, but it's only going to be one word. So provides the services that the computer requires. So I'm thinking it's got to be system, but we'll check this. I'm going to put it in system. System software provides the services that the computer requires. An example is a utility software. Okay. Something software is run on an operating system. Okay, well, we've got a bit of a clue there. Something software. So it's not going to be operating software. What do we install on an operating system? Well, I would say we install applications. So application. It's quite easy, this, isn't it? Well, we've got the answer here. The something system, well, we'll go back to the one I went through here. The operating system is run on firmware, which is run on the, well, where do we install the software? We install it onto a computer. We don't install it into the CPU or the user or the output. We must store it on the hardware, on the computer itself. So we're going to store it on the hardware. The software is installed on the hardware. Okay, nice and easy. That's 4 marks. Very, very easy. Now, question 5. Oh, it's a big question. 6-mark question. This will be the last question on this particular video. A farm. It's all about sensors. This one, there's usually a sensors question, and they're usually quite big, and there's usually an order to basically we'll do some more bullet points. Also, we'll basically be doing some more bullet points, but we'll get the first part out of the way first. A farm has an automated drinking system for its animals. Okay, the drinking system has a water bowl that contains the water. When the water bowl is empty, it is automatically refilled. I'm assuming from some kind of a tap. The system uses a sensor and a microprocessor, so there must be something down here to say the water is empty. Identify the most appropriate sensor for this system. Okay, well, we've got water here. We could have when the water reaches a certain level, or whether it's empty, so a level sensor. We could have a moisture sensor because it'll dry, but that will probably take time. Pressure sensor, because obviously there's going to be a weight here, and when that weight is gone. So I would say a pressure sensor. When there's no more pressure, that sensor's off. But you could, and I think the mark scheme says this, we could have a level sensor, or we could have a moisture sensor. And I suppose these two, or this one, will determine what we write here. Describe how the sensor and the microprocessor are used to automatically refill the water bowl. So we've got, let's put the water in. A picture's always good as well. Diddle-a-da, diddle-a-da, water. On here, sensor. And this is connected to a ADC, an analog to digital converter, which in turn is connected to the microprocessor. And this has on it a database of stored values. Okay, so it's constantly checking. The sensor is sending data from the tank through the ADC data, to the microprocessor and comparing it with the stored values. Periodically, every few minutes, it's sending data to the stored values to the microprocessor, and the microprocessor is checking the stored values. If there is a difference between the what's happening with the sensor and the values stored, then something needs to happen, i.e. the tap needs to get turned on, okay, for water to come out. So let's put that into bullet points. Pressure sensor continues to send signals to the microprocessor. Data is compared with stored values. If values are outside the range, a signal is sent to release the water. An actuator or motor is connected to the tap, is powering the tap. Oh, and just a thought, there might be another sensor here for when it's full, and then that turns off. That sends signals and that gets turned off. When water tank is full, another signal is sent and the water is turned off. What we need to mention as well somewhere, I've got any more room yet, continuous repeating process. Okay, it doesn't need anybody to be there. No need for human interaction. We could mention, it's not the mark scheme, but I think that's quite important. But yeah, I've got 1, 2, 3, 4, 5, 6. So yeah, that would give us our 6 marks. Okay, and a picture is always good. A picture, upper, so you've got upper value, and of course a lower value. Yeah, and that will give us 6 marks. Okay, that is it for this video. I will continue with part 2 very, very shortly. Thank you for watching. Bye for now. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.